Okay, so we have a roller coaster traveling in a loop-the-loop that has the track itself has a radius of 8 meters. Okay, problem, it gives you diameter. And there's a condition here that the force the seat exerts on the riders is half of the force that the earth exerts on them. So that means the force of the seat is 1/2 mg. Okay, so if we look at the roller coaster at the top here, all right, in particular the passengers, we know that the velocity going into the top is going to be tangent right before it reaches the top, and then tangent right after it reaches the top. So to find our change in velocity, we have our final velocity minus our negative initial velocity, which means our change in velocity is going to be directed down to the center. Our acceleration is going to be pointing towards the center. So now if we're looking at the person upside down in the roller coaster, we know that the seat is going to push them down. And we know that the earth is pulling them down. And in this case, we know that the seat is going to be 1/2 that of the earth. Okay, so our force diagram would look like this. And then to apply Newton's second law, we are going to have the force of the seat plus mg over the mass is going to equal to our centripetal acceleration. Knowing that the seat is 1/2 the weight plus the weight of the person over the mass is going to equal, since it's traveling in a circle, it's going to be v squared over r. All right, and we're assuming at that point we're looking for that speed. So the masses will divide out of each term, leaving us with 3/2 g is equal to v squared over r. Multiply through by r, we get 3/2 g r is equal to v squared. Take the square root of the whole thing. And ultimately we get the speed is equal to 10.95 meters